Hello everybody, my name is George Zaimes and I'm from the International Hellenic University and the UNESCO Chair on Conservation, Ecotourism, or Riparian and Deltaic Ecosystems. Today I will be presenting to you the project where we're trying to identify, monitor, and mitigate inland sediment pollutants in order to mitigate these and improve the Black Sea. As you can see, I have a number of different co-authors. And the reason is because it's a multinational project throughout the Black Sea. So we will start with the roadmap so you have an idea of what to expect in the next slides. Firstly, we will talk about the Black Sea and some of the problems that it is facing. Then we will move on to the objectives of this specific project and where the pilot areas are located. Then we will look at the current research activities in some of the pilot areas of the project. And finally, we will describe to you what we expect the conclusions of this project to be. So, where is the Black Sea located? Well, if you look carefully into the small map we have in the corner, it's in the northeast of the Mediterranean Sea. The main characteristic, of course, it is an enclosed sea. The exchange of seawater with the Mediterranean happens through the straits that we can see in the blue circle down at the bottom. And this is an issue because recharge is quite slow. So in these enclosed seas, once it gets polluted, it is very difficult to clean up. In addition, most efforts in the Black Sea to improve its quality have been done in the sea itself or along the coastal areas. But overall, most researchers have stated that right now it is one of the most environmentally degraded regional seas, and significant efforts need to be done to improve and conserve it. We personally believe the reason is because we're not paying as close attention to the river water that's pouring into the Black Sea. Some estimate that it's close to 350 cubic kilometers per year. Most of this water is heavily polluted and is the reason why the Black Sea is degraded. So we need to figure out what is going there and need to find ways to reduce this pollution. So what is the overarching objective of this specific project? Well, what we want to do is environmentally protect the Black Sea by reducing the pollutants and litter that are reaching it. As we already mentioned, the sea is considered one of the most degraded regional seas. Now we're trying to do this with a Black Sea project, which acronym is Protect-Streams-4-Sea. Specifically, we want to stop non-point source pollutants and litter from reaching the rivers, and if they don't reach the rivers or streams, they will not also reach the Black Sea. The reason we want to do this is because there's not been enough focus on the inland pollutants or litter. And once we identify where these pollutants and litters come from, then we want to recommend nature-based solutions. Why nature-based solutions? We believe they're more cost-effective and also more sustainable in the long term. So what do we mean by nature-based solutions? Well, these are solutions that we work with or we embrace how nature works. There are some natural functions on how to, for example, reduce soil erosion. And a lot of these methods are represented here very nicely in this figure that was developed by the Nature Conservancy. There's a lot of different types of nature-based solutions you can use, other ones for the uplands, other ones for downstream. But all of them have the common theme. Let's see what nature does. Some of the most simplistic ones are what? You have a steep slope that is eroding. If you can replant it with forested vegetation, you will reduce the soil erosion. In other areas, you can establish a wetland. Why a wetland? Well, it can keep the water after a rainfall event. And one of the benefits in this case can be, for example, mitigating flood events, but also as the water stays in the wetland, you have denitrification. So the water leaving the wetland is much cleaner, so you can improve water quality. Because the Black Sea is quite large, relatively speaking, we decided to have pilot areas in different countries surrounding the Black Sea. So we have the Baltata River in the Republic of Moldova, which is in the lowlands, mostly agricultural, and in this case our partner is Equateros. We also have a complete different system, a lake, Siriu Lake in Romania, and here we have Buzău-Alomita Water Administration as our partner. In Greece we have a typical stream of the Mediterranean region, Anghiti Stream, and of course the lead partner here in Greece is International Hellenic University. Moving on to Turkey, we have Arhavi River, which is much more steep. It has greater flows, more faster flows. It actually flooded 3 months ago. And in Turkey, our partner is Artvin Çorlu University. And then we have Debed River in Armenia, which is more of an inland area. And in this case, our partner is Young Foresters Union, which is an NGO. We also like to point out that our partnership has universities, 2 universities, 2 NGOs, and a public organization. This was done on purpose because we want science-based information, but also our tools that we develop to be practical. So now we will present to you what the activities of the research project have been during this first year. We must note that the project will last at least 1 more year, so we expect more new and better results. So the first thing that we have done in all 5 pilot areas is the digital layers. We have digital layers of what? Stream network, soil data, land uses, aspect. We also have developed the digital elevation model. This was the first step that would help us develop the other information that we needed. We have been able to detect where we should put the plots in regard to stream bank erosion. In this case, we're using 2 methods, erosion pins and stream cross sections. We've also located where the runoff plots will be, and these will be in different land uses that in the Greek watershed are sclerophyllous vegetation, grazing areas, agricultural fields, and forested areas. Now, we don't want to just use these traditional methods like erosion pins and cross sections or runoff. We want to use new technology such as drones. These allow you to extend the area where you can conduct research and also find some more interesting aspects. We're also using laser scanning because we believe we can increase the accuracy in finding the erosion. And then all this information we want to move from the plot to a greater scale, for example, the watershed scale. So in this case, we're using GIS tools and hydrologic modeling. In addition, we are collecting a number of different soil samples. These soil samples will be from different land uses, but at the same time we will collect samples from stream banks, but also from areas where we can find deposited material from erosion. Here in these different colors you can see soil samples for different, for example, land uses, or if they are from a stream bank or if they are from the stream bed. The reasoning behind this is because we want to use what is known as the fingerprinting method. What you do is you take a soil sample, you look at its chemical that it has in there, different chemicals, and then you also take from an area that this eroded material ends up, for example, the river, delta, or a lake. Based on this, then you can see where the erosion is originating from. On top of that, we're also installing very nice equipment to provide us additional information like this hydrometeorological station that will provide us both streamflow data but also climatic data. Let's now move on to the Turkish plot, where they already have established all their erosion pin plots. They have 23. And in this case, they're looking at the impact of stream order. They believe there might be a difference in erosion contributions from stream banks depending on the stream or if it is a gully. And here you can see some photos with the erosion pins that were installed. In addition, in all these pin plus, they are doing cross sections, and this will allow them to digitize the entire stream. Of course, it is necessary to look at water quality and water quantity. So they are collecting water samples, they are analyzing for suspended solids, phosphorus, and nitrogen. For water quantity, in this case, they're not using a hydrologic station, but they're using pressure transducers. And this is allowing them to know what the stream stage is, and if we know the stream stage, then we can estimate stream discharge. Finally, they have installed their runoff plots. They're quite large in the 5 main land uses in their watersheds, in the Arhavi watershed. Specifically, they've installed plots in low and highland forests, grasslands, and then agriculture areas that either have tea gardens or hazelnuts. Finally, let's talk about what has been accomplished in the Armenian pilot area where they have the Debit River. Firstly, they had satellite images, and then utilizing remote sensing techniques and specifically the NDVI index, they identified the eroded areas. For these eroded areas, they decided to focus on 4 of these that they called the hotspot areas that had the greatest erosion. And in these 4 spots, they have installed Gerlach traps. Gerlach traps are there to be able to estimate surface runoff and soil erosion. And then also erosion pins. Of course, these were done in order to be able to estimate stream bank erosion. They are also collecting, like all other partners, soil and water samples. For the water samples, right away, they're estimating pH, conductivity, dissolved oxygen, saturation and concentration, and also the temperature of the water. So, all our activities have not been completed. We have a lot more data to collect. And we're collecting this in order to be able to, what we said at the beginning, identify where erosion is coming from. Now, if you know where erosion is coming from, how it is being happening, then you can recommend these best nature-based management practices. Of course, these will be different from pilot area to pilot area, but because we have so many different environments, we will believe that we will provide best management practices that are applicable for the entire region. We also believe these will be able to reduce sustainably non-point source pollutants like sediment or nitrogen or phosphorus. In addition, we believe that the methods we're using and also the tools we have developed will be adopted by the entire region. If this happens, it will allow to have a joint monitoring program for the entire Black Sea region to combat non-point source pollutants and litter. So if you like my presentation, please follow us on the social media. We have a number of different social media. We have Facebook, we have Twitter, we have Instagram, we have LinkedIn, we have YouTube. YouTube, actually, we have many very nice videos. So if you want to look at these videos, just visit or follow us. Of course, we have the project website, which has a lot more information than what I presented today. We also have a newsletter, which we produce every 6 months. And we also announce different events on the project website. And now, because a lot of these are also done online, you can actually come and listen to these events. And we would love you to come and participate in these events. For example, we have a network where we present some of our results. And of course, we really like to thank the Black Sea Basin Joint Operational Program for believing in us, for trusting us, for funding this project. We believe in the end we will have very good results that will help the region. Finally, I'd like to also thank all of you for listening to this video. I hope it was interesting, and at this point I will try to entertain if you have any questions. Again, thank you very much.